Hi once more, everyone. Today's class would basically be the implementation of the library management system. The last class, we basically were able to break down what a workspace looks like and how to work with a workspace. And I also broke down the assignments which I gave and how the solution should look like. And so today, the major aim of today's class would be basically solving the assignment and giving the solution to the assignment. So on the call last, I had basically already created, excuse me, I've basically already created the workspace. So let me clear this. I'd already created the workspace that included the lib borrowing, the lib inventory, the lib users, and the library app itself. So for us to start, I'm going to start from the first one, the lib inventory. What are the things we'll be having in the lib inventory? The lib inventory will basically be working as the library that basically holds the inventory of the library. That sounds funny anyways, but that's just the idea. It's going to be where books and literally all the books is, added, removed, and you understand. So for this, let's name it inventory, entry, inventory. Okay, I got that. Okay. Uh, the first thing we want to do is to create a struct. So we make it public. We create our struct and we name the struct book. What are the things that would be inside this book struct? First, notice that everything I'll be making or building with this will definitely be made public. And so for that reason, I'll be adding PUB in front of everything because we are going to be using it outside of this library. So the first thing we'll be having is the ID of the book. For that, we have it as U32. Then the next thing we'll be having will be the title of the book. For that, we can make it a string. Then the next thing we'll be having for that is the author. I mean, what I'm doing, I have basically implemented it before, but I will just quickly re-implement it since we are just basically making this something. Oh, I've written the author. The next one should be the January of the book. So for this, I would call it January. The January, I'll add it January. But then notice that this is a problem. We've not created this data type. What exactly would the data type be? It should be a struct which we'll be creating. Then we also need to check or know if the book is available. So we name this available. And we make it a Boolean. So that's that. We definitely have this error. And before we proceed, let's just quickly add the derive debug. So we can basically print. Let's also add clone. So yeah. Now for the January, we are going to basically create an enum for the January. And this enum is basically, it's also going to have, let's just copy this and paste here. And for it, we make it public enum. And we say January. And then what are the things? We have fiction. It would have a fiction, non-fiction. Oh, did I just call this friction? Non-fiction, then science, then history, then fantasy. Then lastly, we can have others. Let's have others. And for the others, let's add a string here since we don't know what it is basically. So yeah, so now we have our book struct that includes the ID, the title, the author, the genre of the book, and also to check if the book is available. Then for the genre, we have fiction, non-fiction, science, history, fantasy, and others. So next, what we'll create next is then create an inventory. Make a struct and name it inventory. Did I spell it well? Sorry. Okay. And for this inventory, we have all our books in a vec. And inside the vec, we have our books. So basically, yeah, it is. So now we've implemented this before, our books, January, and then the inventory itself. So for the inventory, we would basically be doing something. We would be implementing it. So we would implement the inventory, and then inside it, the first thing we would have would be new, function new. What will new do? It will create a new inventory and it should return the inventory itself. Basically, so for this, we would have self books, and then this should be a vec new, basically, since it's new. So I like spacing this out and, making it have its own line. Okay, that's our first function. Our second function would be to add book. So we have function add book. And then for that, it will be a mutable self. Then the book we want to add. And then we add the book. Up to this point, I want to believe everyone is still with me. And we are basically, okay. I want to believe everyone is still with me. Okay. And there are no questions for now. So why I'm doing this fast is because we have basically implemented this part before. And what we are doing is not something we do not know before. So this is basically to add books. So self.books.push to push in new book. Now another function we'll be creating is a function to remove book. So function remove. It's also going to look the same way because we'll be mutating this, and then we'll pass in the book ID we want to remove. Since we can remove it either by the book ID or by the name. So U32, we can make it U32. And so we return an option of books, or book. Yeah, and for this, so we check if let sum. Remember, I explained what sum is in the past. We name it POS. And then it's the self.iter. And then we check for the position of the book. POS is literally like a short form for position. So position, dot position. Then for the dot position, we know dot position is more like it's more like a method on an iter, and this is literally something I've explained in previous classes. So we look for the book position. So book.id, if it's equal to the book ID, then what do? We remove it. So self dot books dot remove. That is what we do. Then else none. self.books. We didn't add the books here. So that's basically to remove a book. So the next one we'll be doing is basically a function to get books. So for this, we make the function get book. So we want to get a book, and this time it's not going to be a mutable reference to itself. So we add the book ID we want to get. It's a U32, and then an option book. And then for to get a book, all we have to do, since we are searching for it through the book ID, just a self dot books dot iter, then dot find, and then we find the book. We add the reference to it, the reference of the book, and then let's say the book is equal to this. Then if it's equal to the book ID we are looking for, it should return it to us. And so this is basically going to return the book based on the book ID we searched for. So for this, we've implemented to create a new book. To create a new book, we've implemented to add a book. We've implemented to remove a book. We've implemented to get a book. So the last one we'll be implementing would be a function to list all the books available. So list books. It's going to take a mutable self-reference, and it's going to return the books. So it's going to be a reference, actually. This isn't allowing me to see what I want to see. Okay. Going to return the reference of the book. To do this, it's just going to be self.books. So it's going to return all the books inside of this inventory. And with this, we have literally completed our implementation for the inventory. So we are literally done with this, the lib inventory. But we are told to always do what? To test. So each of the libraries should have unit test for its core function. And so for this, we're actually going to, create a test for every one of it. And so we move back to what we are working on. But before we proceed, I understand that we have actually, we have actually done this part before as a classwork, but not in a workspace pattern, because now we are trying to enhance the whole workspace pattern, create tests for each of it, and create, different modules to create a full functional app. So that's exactly why I did not pause to ask if there are any questions. But right now, I'll still ask if there's anyone on the call that have a question for me right now. So if there's any question, you can raise your hand. But if there's none, you can give me a thumbs up so I can just continue the class, basically. Okay. Okay, great then. So since I got a thumbs up to continue, I'll then add the test. So I think we have the test already here. Okay. So here is what the test look like. I've explained what the test looks like before. So the first one is literally super, and it's what it does is it imports everything that is here. I think someone raised the hand. Okay, Kobzi, you can unmute and speak.
Okay, and sir, for that list books, can I please see what you wrote again?
Yeah.
Yeah, you're just basically just returning all the books. Does that include
Ex-
the name, the ID, the author,
Yes,
everything?
yes, yes. It basically
Okay.
includes everything. It includes all
Uh,
the books in the inventory. It's literally just returning this.
wow. Okay.
Yes. This is slightly different from the last implementation, right? The last
Yeah.
implementation looked through it and I was listing them one by one. But for this, I want to return the full list of books. So it's just going to return a vector of structs. You get that?
Yeah, I get it. Returning a vector instead of returning
Yeah.
normal.
Instead of listing it. Yeah. So since what we'll be working on is quite enormous, we would be having just one test for each of the libraries. And each of these tests we'll be doing will actually cover the full library. So for these tests, oh, I named it, it works then. What do I name it now? Let's call it test add and remove inventory. It's always nice when you name, that's an add remove book. It's always nice when you name or test based on what they are doing. So what this test will be doing for us is we will test adding and removing a book. So the first step obviously is to create an inventory. Inventory. And to do that, we say inventory new, basically. So now we've created an inventory. One additional helper function we could have added is a function that basically, creates a book for us. And I showed us from the last class how we can basically just add that helper function. But no, we won't be adding that helper function. Let's create our books manually. So we will create a book. And for the book, it should have ID. For the ID, let's name it one. Let's the ID be one. The title, let's name the title the Rust programming book or the Rust book. Let's just name it the Rust book so we don't take too long. Let's use dot to string. Yep. We could also, I'm not the owner. We could also do string from instead of to string, but anyone you like. I'm going to say Ayo. Oh, let's just use a real person, Steve. Then, what's the next thing? January. For the January, we have the different Januaries available. So, let's say it's a book of science. I mean, the Ross book is literally a book of science. So, yeah. Is it available? Yes. Nobody have borrowed it. So, true. Okay. So now we have our book. So let's test adding. To test adding, we will say inventory dot add book. So we've literally added the book here. So as at this point, we want to believe that the book have been added. So we are going to assert equal inventory dot get book. And we are going to get the book by the ID. And we unwrap it, dot unwrap. Dot, we want to see if the title corresponds to the title I gave to it. I said the Rust book, right? The Rust book. And then we add this. So let's cargo run it. I mean, cargo test it. So what we did is we added the book here. Now we are certain that the book, we are trying to get the book with the ID1. If the book with the ID1 is there, the title of that book should be equal to the Rust book because that's literally the ID one. So this is just what the testing looks like. So for that, we are going to cargo run it and we would see if our test passes. And here it is. It works. Our test works. But for you to know that, okay, this is actually working, I'm going to remove K, or let's just remove book. Let's name it the Rust. Let's see what the test would look like. Can we see? It failed. This is because what is on the left hand is the Rust book. What this is returning here is the Rust book, but what we are equating it with is the Rust. So obviously it would fail. And so this shows that our test is actually what? Our test is working. But remember that I said that we are going to be testing for add and remove books simultaneously. So for that, we are going to add the next test to it. So for this, we will say let's remove book equals inventory dot remove book. And what is the book ID we are removing? 1, right? And for this, we are going to assert that remove book is sum. Okay. We are also then going to assert that inventory dot get books, with the ID 1 is no longer there, it's none. So as at this point that we are removing the book is actually there. But the moment this line of code reaches line 80, the book has been removed. And at this point, the book becomes none. So because the book is removed, is sum is still there. That is exactly why we are doing what? We are storing it in this variable, remove book. And so storing it here is going to return an option, and a sum is literally going to return a Boolean, true or false. And so if it's true, then our test passes. And at this point, if we get book should be none because 1 is no longer, the book with ID 1 is no longer there because we've removed it. So let's run our test. Yes, our test is passing. So this passing shows that we actually were able to add a book to the library. Yes, to the library inventory. We also were able to remove a book from the library inventory. So we could say our test passed at this point. So yeah. Does anyone have any question at this point? Does anyone have any question at this point? Okay, I'll proceed then. So now that we've been able to work on the inventory, the next thing we'll be working on now is users. I like my screen, it makes it look nice anyways. So for this, I'll do the same thing. I'll do this users library, users lib. Okay, what are the things we need in the users lib? Yeah, since we have this, we want to create a struct for the users. And since we'll be creating a struct, it's obvious that we definitely need to clone it and to print it out. So we just have the debug and the clone. So for that, we'll add the struct and name it user. So this struct is for each of the user that is coming to the library. So remember, we are building a library app. Okay, no problem. You can go through the recordings later on. So remember we are building a library app. So now we've built the section of the application whereby a person can, whereby a book can be added to the library by the librarian, obviously, and then we've built how the book can be removed. We've also tested it. Now we are moving on to the part of the users where a user can come and basically, request to, borrow a book. So what are the things needed here? We obviously need to register a user before a user can basically use a book. We need to create a method to get a user if it's part of the management system, whether he has actually registered before. We need to know. So we want a function that can literally return a user's data. Then another function we also want is a function that can basically allow a user to borrow a book. So a user should be able to borrow a book. So we want a function that can allow a user to borrow a book. So yeah, so we are going to proceed now. And to start with, what are the things we need to know about the user? Well, every user needs an ID. So we can get his detail just based on his ID. So for the ID, we make it U32. What other thing do we need? We need the user's name. For the name, we can make it a string. What other thing do we need? List of the books you have borrowed. So we can name it borrowed books. And for this, it's going to be a vector of U32. That's the ID of the books he has borrowed, basically. Then, what's the next thing we would do? We would have to create the list of users. So to create this, we make this user manager. That's list of all the users. So I didn't add the struct in front of it, user manager. And for this, we create, make it public actually. Do we make it public? No, let's not make it public. Let's make it private. It should include the users of, the library. So this would include the users. So yeah. So now, what's the next thing we want to do? Next thing we want to do is now to implement all the methods that each user can basically call. So we will implement user manager. So to implement it, obviously, most times the first function we're always creating is a new function. What does the new function does? It literally creates an instance of the struct we are implementing. So we return self, as self is literally the instance of the structure we're creating. So for this, obviously, we make it a vector, a new vector. For this, we use new. And just like I said, I like having all of these stuffs on a different line. It makes it look good. So the next method we create is a method to, a method to register users. So what does the method does? It literally registers the users. So it takes a mutable self and the user it wants to basically, let me drag this to the side. Okay. So it takes in a mutable self and the user it wants to basically register. So it takes in a user struct. So what are the things it does? It basically pushes the user self dot what's the name? Users, self dot users dot push a user. Basically pushes the user inside. Cannot return anything, so let's just add that semicolon. The next thing we would be adding to this is basically a function that gets a user, and we'll be obviously, just like we did in the inventory, we'll be making use of the ID. I mean, ID is something popular that most architectures use to, to identify different users, different data, basically. So each user with different IDs, each book with an ID, and it's basically easy to have different books. Like now, you could have Rust book, different Rust books, but if it have an ID, so this ID could be different from the ID of the other Rust book with different, different authors. So that's just literally one nice thing about having an ID. Or imagine a user have the same full name with another person. Imagine he has the same name. What are the things in our user? The same name, and this person has borrowed these exact same books. Okay, you have a question? I'm listening.
Yeah, so can you please share your code again? Okay,
Yeah,
for that, when you created the implementation of the new user, when you said pop fnu then self, is it the same thing as saying that instead of writing that self, so it's same thing as saying like maybe calling the user manager struct there in that self? Is it the same thing
exactly. It's literally
or is
the
it
same thing.
different?
Yes, it's the
Okay,
same
okay,
thing. I can do this. You see, no compiler error. I can even put it here. Still no compiler error. Remember, I explained to you in very, very old class, like previous class back, that um, the struct itself that we are implementing it would include it having methods, and having methods means it basically is acting like a class. So we could think of it in an object-oriented programming manner, and in that sense it could be self or the name of the class, and in this case the class is more like a struct. And so, but for this, I'll just leave it as self, just to make it look good. So it's the same thing. So moving on, the function I said we'll be implementing next is a function to get a user. So we name it get user, basically. And I said that it will be taking in the user ID. I mean, the user, more than one user could have the same name, but each user have different IDs. So once you export your user ID, they pass it in, and you can basically use this to get the information of the user. So for this, we would add self and the user ID. And this will be a U32, since the user ID here is a U32. So the next, it should return. A situation could be whereby the user is not actually, it didn't register. Imagine you go to the library. You remember we are building a library app. You go to the library and you want to borrow a book, and they're like, what's your user ID? They type in your user ID, but you have not registered before. How do we handle that situation? So we are going to use an option enum to handle this situation. So it will either return the user's ID and the user's information, or it would return none. So to do this, we are going to literally use self.users. We will get all of the users. Then we make it into an iter. Then we find that user. What are the things we would add? We'll make it borrow. We will borrow that. This is a closure, like I've explained in previous class. Then the user ID, if it's equal to what the user is passing in as his ID, then we return it. If not, if it is not, okay, this is saying we are expecting a borrowed option enum where we are borrowing the user, but what we are returning here is different. We are returning a borrowed one, but then what we returned here symbolizes that we are not borrowing. So let's just add it here. We add this, and this problem is solved. So whatever you are borrowing, you ensure that you are borrowing it. Yeah. So I am borrowing it because obviously I do not want to just take out the full data from where it is. Rather, I want to borrow it. So borrowing it is just like a reference to it. So this reference is literally referencing to the user's data here. So the next thing we want to now implement is more like, the main function in this part. which is definitely going to be the borrow function. Yes, it's not the only function. I mean, it's not the only main function. I mean, if you do not register a user, how can you even borrow? But I mean, yeah, we would be implementing the borrow book function. Have we implemented borrowed books before? Why is it highlighting it for me? So to borrow a book, we would make it mutable, and it's a mutable self. The user ID, we want to get his ID. It's definitely a U32. Then we want to get the book the user borrowed. So we take the book ID the user is trying to borrow. It's going to be a U32. So what are we going to do? We say if let sum user, okay, is equal to self dot users dot iter. We want to mutate it right now. So we are not just iterating through it, we are mutating it. So we use iter mute and then dot find. Now we want to find that book. Dot find. No, what we want to find is the user ID. Okay, this returns the user. So we want to find u.id. We want to ensure it is equal to the user ID. If it's equal to the user ID, then the amount of books the user have borrowed. So we say user dot borrowed books. We are going to add the books you have borrowed inside here. Is borrowed books. We're going to add it here. And to add it, we'll be pushing in the book ID borrowed. So let's give some space. And so, yeah, basically this is it. So we've basically find the user. And after finding that user, if it's available, the book you borrowed, we are going to push it inside this book ID. So these are the list of the borrowed books. Does anyone have any question at this point? Anyone have any question?
Can I please see the stuff again?
Let me close this side. Yeah. So basically, it iterates to it. Notice that this iter I use now is a mutable iter because I'm trying to mutate whatever it returns to me here. And what it returns, I destructured it by using this if-let to destructure the results it returns from using this find method on the iter. Then I destructured it by using this sum. And what I destructured, I used it by pushing in the book ID the user borrowed, taking it here. Did you get that? Okay.
I have a question. Like, you know, when you're creating it, I think that when you register, yeah, register user, yes, and I think you call the user struct, right? The user struct. Why calling the user struct? I think one thing that was defined in the user struct was the borrowed books, the vector borrowed book. So does that mean that when the user is registering for, as in that's trying to register with this register function, that I don't know, the borrowed books variable is being filled or it's not being filled, like, or is it filled a default value or doesn't really affect it? I don't know what's going on when the register function is being called.
So you mean what's going on when this is being called?
Yeah, the borrowed books variable, is it being filled up to, or nothing happens
Exactly.
to it?
What happens is when you call this borrow book function, it's going to first of all look for the user that wants to borrow it, and that this is where it does it. It gets this users is list of all the users in this library, in this user manager. You get. Then I use this method, find it, and then it finds it based on the user's ID. And the moment it finds the user's ID, what this itself return is a struct of user. And so that struct, I went into the struct and I clicked on the borrowed books. And then the borrowed books, remember, it is a vector. And so these borrowed books, I'm trying to push in the book ID the person borrowed. So that means that the user have automatically borrowed this particular book. But remember, we are not yet done. And so obviously, there should be a threshold to how many books a person can borrow, right? All of that is what we are going to definitely be implementing as we proceed. But for now, okay, I'm listening.
But the register function, like the bold books vector, is not as I don't get the fact that okay, when you register the bold book variable, like isn't being called to like say like a default value that will just like um I don't know the right words to use right now.
I get what you are trying to say. You are trying to say what is stored in these borrowed books, right?
Yes, yes,
The moment a new user is registered,
yes.
what is inside these borrowed books? But the answer is that nothing is there.
Oh,
It's an
so it's
empty
zero.
vec. Exactly. It's an empty. It doesn't necessarily. Let me show you an example of something. Where do I do it? Let me just do it here inside this function. It's something I'll clean. If I can say let's empty, just name it empty equals an empty vec. This is an empty vec.
Empty vector.
Yes, let me just add an annotation to it. Let's make it a U32. So this is what it looks like, an empty vec, not zero. It's just an empty vec. Did you see that?
Yes.
So if I print this, it's exactly the same thing that it would return to me, that this, where is it? This would return to me.
Okay, which means when a user registered, it creates an empty vec.
Exactly. It's just like, yes. But then remember that whenever a user register, it calls a user register. At that particular point, the user is imputing everything, all his details. You remember that at this particular point here. So that means in our test function, if we are testing register user, what we are going to be testing is we definitely be filling up this user. But at that point, we would definitely fill it up with just this and this. What exactly would we be filling this up with? I mean, that your question is in fact something that would even be shown in the test. How exactly are we going to do that? Would it be like this? Would it be an empty vec? Well, let's see what happens when we are testing it. Does that answer your question?
Yes.
Yeah, okay. So I would continue. So we've implemented borrow book. I mean, someone that borrows a book should literally return the book. So let's implement return books. Okay, so returning a book will obviously mutate the states, and we want to get the user ID that wants to return. It's a U32, right? And then we want to get the book ID is trying to return. So for this, it's just basically the same thing that we've done. So if let we get the user is equal to self.users dot iterate mute. We are mutating it since we are removing it. Dot find, and the find is literally a method on the iter. And what are we finding? We are finding the user, right? So we're finding the user dot id. User id. If it's equal to that user, if it's equal to the user's ID, it should do something. What should it do? User dot borrowed books dot retain. We want to retain the book by the ID and so on. If this particular book is not part of the book ID, let's retain the remaining ones. Did you get that?
Yeah.
Okay. So basically, we use this method retain. So the retain basically retains anything that is not that we want to remove. So it retains the rest and remove this.
Okay, so please explain that line again, line 38 and 39.
Okay. So remember, this is literally this. It's literally the same thing.
Yeah.
We go through our user manager inside this vec. We iterate through it. We make it a mutable iter because what we are finding, we want to mutate it. We make it a mutable iter, and once we find it, it's going to return it to us as a mutable variable. And now we now got it inside it. We now clicked on borrowed books, this one. Now we are now trying to remove this book ID. Removing this book ID from here would mean that other books that he has borrowed will definitely be there, but just this one would not be there.
The index of that book that I borrowed.
Yes. Remember that the book ID is the only thing we are storing. If you look at the inventory, the book ID can get us the whole information about the book, right? So now what we are doing here in the user library is trying to return the book based on the book ID, and we are only keeping the book IDs that the person borrowed. We are not keeping the full name of the book, the author. No, the only thing we are keeping is the book ID the person borrowed. So it's easier to just go and check the book ID here. You get?
Okay. Well, why didn't you use the dot remove index function instead of retain?
That's because we do not know the index. Did you get that? Imagine
We
we
are
knew the
searching for the
index. Exactly. Imagine we knew the index. Notice that is the book ID the person supplied to us. Can you see?
wait.
It's the book ID that was supplied to us.
Okay. We are looking for
Not,
the borrowed book ID.
yes. You know the borrowed book ID, yeah. The person might come and he might return the first book he borrowed. Imagine the person has borrowed 3 books. Imagine if the library has that, okay, person cannot borrow more than 3 books. Now the person returned the first book it borrowed. And the person, remember, the person have already borrowed 3 books, but he returns the first book he borrowed. Now, in that case, inside this vector, let me create what it will look like. Borrow. Let's just name it borrow. You say let borrow equals, it should be a vector. Let's check the name. Vector U32 is equal to vec. Let's say the book ID it borrowed is 2434. The second one it borrowed is 143. Then the last one it borrowed is 983. Let's say this is what is inside. This is what the person borrowed. Are you listening?
Yes, I am.
Okay. Let's say this is what the person borrowed. The ID of the first one he borrowed is 234. The ID of the next one he borrowed is 143. The ID of the next one he borrowed is 983. Now we could actually loop through this. We could actually loop through this, and sorry, I think my lights went off. Let me quickly, give me a second. Let me quickly bring that on. Very sorry for that. Okay. It should be up in a second. I really did not know why it went off like that. Okay, it's up. So we would continue on there. Okay. So what was I explaining here? Here are the books the user borrowed. He borrowed a book with ID 234. Then the second one he borrowed was ID 143. That's the book ID. Then the next one he borrowed was ID 983. You understand? So now he came back and he wanted to return this second one, ID 143. Remember that the user basically does not care about the position of the book. So he doesn't know the position of the book. He cannot come and tell them that, oh, I borrowed, it's the second book I borrowed, I'm returning. No, that doesn't make sense. What if he borrows more, he has returned more, and then the lost count of which one is the first or the second one? He can't come back to say that. What he will say is, I want to return this book, and this is the book ID that I'm returning. It's literally going to be on the book. The book ID I'm returning is 143. So we know the book ID, but we don't know the position. So the best method to use here is this retain method. Look at what it does. I want it to bring out the name. So it retains only the elements specified by the predicate. So in other words, it removes all elements for which the closure, this function is literally the closure, returns false. So this method operates in place, visiting each element exactly once in the original order and preserves the order of the retained elements. And that's exactly what it does. It retains what is false. And in this case, if this ID is not equal to this, it retains the rest. So does that make sense to you?
Yes, it does.
Okay. So now we have basically implemented all the functions we need for the user manager. So for the user manager, what is left for us to do is to test it, right? And so to test the user manager, we would name the user manager, what should we name the tests? Test, register, and borrow books. So let's name it test, register, and borrow books. It's important that you always write a test for anything you are doing. So that's exactly why we are learning how to write tests too. So yes, obviously, this kind of application we are building is actually a very big application. In fact, if you want to, you can actually re-implement everything we've implemented in the Soroban smart contract. I understand that we've not started teaching the Soroban smart contract. And in fact, the Soroban smart contract will start teaching that right from next 2 weeks. So next week, what we are going to do is, obviously, with the time, we definitely not be able to finish all of the implementation for this library management. But on Monday, we will definitely do the remaining parts that includes, we've done the library users, then we've done the inventory. So borrowing, we've not implemented borrowing. Let me see, we've not implemented borrowing. So we'll be implementing borrowing and then the main library app itself. On Monday, we'll be doing that. But for today, we are going to finish it up by writing the test for borrow. That's the users. Do we need this? We don't need this actually. Is there somewhere we are using it? No. So we don't need that. Okay. So for that, we will write the test now. The first thing we'll definitely be doing is to create an instance. Let's mute user manager. We create an instance of the user manager struct, and for that, we call it user manager .new. And so this is an instance of it. Then the next thing we definitely do is to create a user. Obviously, it's so easy for us to create an helper function that helps us create a user, but I mean, let's just do it like this. You could, this is actually a full application you can build. So you could also expand the application by adding more functionalities, like actually having a function that literally does something. And what it does is, create a user. So for this, we will just be doing it manually. And for that, it has an ID. Let's say the user is the first user. I'm the first one. The name, we are going to name it Ayo. String from, remember we have different ways of doing it. String from Ayomide. Yeah, that's my name. And then borrowed books. The borrowed books. Now, this is your question. It's going to be an empty vec. Going to be an empty vec. And to do that, name it new. And for this, we add a semicolon at the back. So in the user management manager, what we want to do is we want to register a user. And who is the user? This user, me. We want to register me in it. And then what do you want to do? If we register me like this, that means we automatically used this variable, but we want to be able to use this variable again somewhere else. So for that reason, we are going to clone it. We won't use it just like that. So we will clone it. Then to show that we have actually registered the user, we are going to assert equal. These are first tests. We want to assert equal that the user manager dot get user one with user one ID. We want to unwrap it, unwrap dot name, because it's definitely going to be an option enum. It's going to return. So for the option enum, we are going to unwrap the option enum. As you can see, it's literally unwraps the option enum. And after unwrapping the option enum, what we do is we bring out the name from it. So the name is the name Ayomide. Let's see if it's Ayomide. Okay. So we are going to test it. Let's clear our console first. Clear. So we can go run it. No, we won't cargo run. Instead, this time we are cargo testing. Yes. Where is our test? Our test of test register and borrow book. Okay, here it is. Test register and borrow book. So yes, our test is working. And also, like I said, we can basically just, test just that particular test. And here it is. It will include the remaining tests. As you can see, the remaining tests are ignored because we are testing just that particular test. So test register. So we can see that, yes, the book we registered is actually there because we are testing it by testing the name. So it's actually Ayo that is registered there. So The next thing we want to test now is, since we've tested to register, we also want to test borrowing a book. Let's test to borrow a book. Let's see if it borrows, it actually stores it there. So we're going to say user manager dot borrow. Who wants to borrow it? Ayo. What book ID does he want to borrow? Let's go and look at that one I added here. 143. I forgot to remove it here. He wants to borrow book ID 143. And yep. So I've borrowed that, and so let's check if the book I borrowed is actually there. So we want to assert that this particular book 143 I borrowed is actually there. So for this, we're going to say user manager dot get user. What's the user ID? 1. Then we would unwrap it. And then the books we borrowed, we want to say dot contains. We want to see dot contains. If it contains, we want to see if it contains, if what we borrowed contains 143. But this time, I want us to check if it contains a different number. If the book we borrowed, let's see if our program can lie to us. Let's see if it contains a different number when it actually does not contain a different number. So for that, we are going to just add a different number, 234. And we are going to run our test. Okay. This should actually be borrow. Okay. So let's run our test. Fail. We notice that one failed. Which one failed? Test, register, and borrow book. Why did it fail? This is because this 234 is not part of the books I borrowed. 234 is not part of the books I borrowed. As you can see, test, register, and borrow failed. 234 is not part of the books I borrowed. But if I put 143, which is the book I borrowed, it should then pass. Yes, it is passing, as you can see. Test, register, borrow, and book. It is passing because 143 is basically part of the books I borrowed. And so that is how we come to the end of today's class. That includes us implementing both the inventory to add a book and to remove a book. And we also tested it. Then for the users part, we also created the user to register a user, to get a user, to borrow a book, to return a book. So next week, we'll be continuing. Okay, what's your question?
The unwrap, when is dot unwrap being used? I thought you said something about unwrapping an enum.
Yes, dot unwrap is used when you are trying to unwrap an enum. What this returns to you? I said an option enum. Can you see? What this get user returns to you is an option enum. Look at it. Get user.
Okay.
Look at it. We are returning an option enum. So we are unwrapping the option enum. And so we unwrapped it. Anywhere you see unwrap, it's literally to get the value inside it. So you can use unwrap or default, but we can't use or default here because we did not use the default street when we were working with it. So, yeah.
Okay.
Does that make sense?
Yeah.
Okay. So this is how we come to the end of our class. Thank you very much. I would now stop the recordings. So next class, we would continue from where we stopped.